Galvanic cell, voltaic cell, Daniell cell. The purpose of these cells is same and the concept is also going to be same. There is a small difference between the galvanic cell and Daniell cell. We will discuss all those. Okay. First, it is a container in which zinc sulfate aqueous solution is present, and here a zinc rod is there. Here one more container in which copper sulfate aqueous solution is there and a copper rod is present here, inserted into that one. Zinc rod in zinc sulfate, copper rod in copper sulfate. Okay, they are connected as you connect in your physics. Okay, connected, and these two are connected by a inverted U shaped. This is a U shape. Okay, now which we call salt bridge. Salt bridge is generally made up of agar-agar gel with potassium nitrate, ammonium chloride type of salts we generally take here, potassium chloride. The only condition is their mobilities must be same. Potassium nitrate mobility same, ammonium chloride mobility same, potassium chloride mobility should be same. They are filled here. Their main job is to prevent the accumulation of the ions and the electrodes. Okay, now that part you will learn soon. Now what's happening here, you see, it is a container where zinc sulfate aqueous solution, into that a zinc rod is immersed. Another one, copper sulfate aqueous solution, into which a copper rod is immersed. Both are connected externally, okay, and internally by a salt bridge. What actually happens here is zinc undergoes oxidation. Okay, now left hand side what we have given is it is undergoing oxidation. Zinc loses its electrons and becomes Zn plus 2. Whatever the electrons zinc is losing, all those electrons are traveling from here. So electrons are moving from zinc to copper. Zinc is anode where oxidation is taking place, but this anode is given by a negative sign because here electrons are there. Here electrons are released by the zinc. So electron density is more like that. So it is given as anode. Anode is generally positive, but here in the anode is negative. That is the speciality. So electrons are moving like this. So electrons are reaching this place. So this is in need of electrons. So this is given with a plus sign and this is called cathode because here cathodic reaction takes place. That is copper plus 2 ions from the solution gain the electrons which you are getting from this side and they are turning into copper. Copper plus 2 is converted into copper. So this is reduction taking place at the right hand side. Oxidation is taking place at the left hand side. Overall, this setup is called galvanic cell or you can say voltaic cell. If you are using Daniell cell, this salt bridge won't be there in the Daniell cell. Instead of that, we will be having a porous diaphragm will be there in Daniell cell. Concept, everything is going to be same. Zinc and zinc sulfate, copper and copper sulfate. What actually happens here? Zinc is losing electrons to form Zn plus 2. Okay, now those Zn plus 2, again electrons are here. So there is a chance of coming zinc plus 2 to the electrode. So we need to avoid that one. That's why we are taking a agar-agar gel with KNO3, NH4Cl, KCl, all this. So zinc plus 2 ions are there, na? So anions like NO3 minus, Cl minus anions will be here at this area in the agar-agar gel and they will be attracting the zinc plus 2 ions in order to avoid the accumulation of the ions at this place. Second thing here, copper, we are saying copper plus 2 is converted to copper. That means copper is going to be deposited here, extra copper deposited here, and this zinc is going to be becoming thin. Okay, now some zinc part is going to be out because that is dissolving here. So sulfate ions will be there. Those sulfate ions also there is a possibility they will run behind the copper. In order to avoid that one, okay, now though copper plus 2 ions, sulfate ions can go behind the copper. In order to avoid the sulfate ions towards this one, we have some cations like potassium, ammonium to attract the sulfate ions towards this salt bridge cell. Okay, now salt bridge job is to avoid the accumulation of the ions at these places. So here zinc is dissolved into zinc plus 2. Here copper plus 2, which is in the dissolved state, is converted into copper. Here it is oxidation, here this is reduction. In the Daniell cell or galvanic cell, the overall reaction is zinc plus copper sulfate giving you zinc sulfate plus copper. Zinc to zinc sulfate is oxidation. Copper sulfate to copper is reduction. This is the overall chemical reaction what is happening. This is going to be definitely a redox reaction because a reduction is there as well as oxidation is there. You can call this is a redox reaction. And what we mention here is, you see, zinc by Zn plus 2 or ZnSO4, whatever it is, with the concentration, whatever the concentration is there, 1 molar, 2 molar, whatever the concentration is there, two parallel lines, copper sulfate, whatever the concentration is there, okay, now see, one vertical line copper. Zinc by zinc sulfate, when you are showing with one vertical line, this is called one single electrode. Okay, now this is a single electrode, and that is again a single electrode. It is also a single electrode, and these two lines are salt bridge. So what is the meaning of this one? Zinc by zinc sulfate, which is given at left hand side, undergoes oxidation. LHS is oxidation, RHS is reduction. This is also one shortcut type. When you are writing left hand side, that part should undergo oxidation. Zinc undergoes oxidation to form Zn plus 2. Copper plus 2 undergoes reduction to form copper. Okay, now like this, when you are showing, this is called a cell representation. Cell representation. Vertical line. Okay, now this is a single electrode. Vertical line, it is a single electrode. Both single electrodes are separated by two parallel lines at a time. That is two vertical lines we are showing parallel lines. That is showing the salt bridge. Okay, now left hand side is oxidation, right hand side is reduction. So zinc is converted to zinc plus 2, copper sulfate. You can show this like this also. Zn by Zn plus 2, whatever the concentration is there. Copper plus 2, whatever the concentration is there, copper. Like this also you can show. Or Zn semicolon Zn plus 2. Instead of one line you can show this one also. Copper plus 2 concentration semicolon copper. A single line, in place of single line you can even mention a semicolon also. EMF, electromotive force of cell, is equals to ERHS minus ELHS. Remember only one formula, don't confuse, remember only this formula, but remember the values must be SRP values, standard reduction potential values. Standard reduction potential values. For this particular zinc copper sulfate reaction, the values I mentioned, okay, there is no need to remember the values. The values will be given to you in the question. Zn plus 2 by Zn, E naught value. This is reduction. You can see Zn plus 2 by Zn, E naught value when they are mentioning. So they are showing you the SRP value. Okay, the standard reduction potential value. E naught Zn plus 2 by Zn. This value is minus 0.76 voltage. Similarly, E naught of Cu plus 2 by Cu plus 2 by Cu is plus 0.34 volt. The values will be given in the question. There is no need to remember. There is no need to remember. Okay. Then you see, this is present at left hand side. This is present at right hand side. And the values must be in the reduction potential, SRP values. So given reduction, we see Zn plus 2 by Zn. This is reduction only. Cu plus 2 by Cu. This is reduction only. If it is given reverse, Cu by Cu plus 2 means that is oxidation potential. Zn by Zn plus 2 means that is oxidation potential. But you can see Zn plus 2 to zinc, reduction potential. Cu plus 2 to Cu, reduction potential. Sometimes some books they will mention whatever the way they express here, but in the brackets they will give you reduction potential, oxidation potential. So be careful while you are answering that question. Now, what is right hand side? This is right hand side. What is the value of right hand side? Plus 0.34 minus What is left hand side? Zinc by zinc sulfate. What is its value? Minus 0.76. It is plus 0.34, and this is minus into minus again 0.76, that is equals to 1.1 volt. So galvanic cell, okay, our voltaic cell EMF under standard conditions is going to be 1.1 voltage. This is a fixed value. Okay, now I remember only one value. There is no need to remember the values. Okay, now they will be given in the question. So only formula that you are going to apply is EMF of cell is equals to ERHS minus ELHS. RHS means right hand side, LHS means left hand side. Remember, both the values must be standard reduction potential values, SRP values must be given like this. Okay, now left hand side always in your representation of the cell, left hand side must be always oxidation, right hand side that must be always reduction. Okay, so in this way you can calculate any, but this is applicable only when the concentrations given are 1 molar. Okay, now unit concentrations when that is given, this is the right answer. If the concentrations are different, then you need to apply Nernst equation. We will discuss about that Nernst equation next session.